NAB cos theta. It is a scalar quantity. Then its dimension, unit is Maxwell or standard unit is Weber. Today we are doing Faraday's law. Faraday's laws of electromagnetic induction. See, Faraday observed that if there is change in flux associated with closed circuit, always EMF is induced in that circuit. So what he did, he placed one coil in the field. He found that there is no EMF or current generated. Then he started changing the field. He found that there is induced EMF. Then he made field constant and started changing the size of this coil by pulling or by compressing. Still he found there is some EMF induced. From this he concluded not by constant flux but by changing flux. Flux means this NAB. When you change this flux, then only there was EMF induced in the closed circuit. So first law states that whenever there is change in magnetic flux, to change magnetic flux I can change B, I can change A, I can change this angle of rotation, that means theta. So whenever there is change in magnetic flux associated with closed circuit, then always EMF is induced in that circuit. See, we are using the word closed circuit. If circuit is closed, then current will flow. EMF will be always induced whether circuit is open or closed. But to be precise, we are writing closed circuit, EMF is induced. Indirectly, even open circuit current will be, EMF will be induced, but current will flow only when circuit is closed. So first law states that if there is change in flux associated with closed circuit, EMF is induced, current will flow. Which quantities I can change to get the change in flux? Hello?
Magnetic field and area.
We can change area, we can change field, we can change angle of rotation. ये कोई भी change हुआ तो flux change हो जाएगा. Right, first law. Highest, Ashlesha, you got mark in magnetic field 172, I think, correct na?
Yes, sir.
Yes, please keep it up. First law completed. Till then I'm explaining second law.
Done, sir.
Okay. Second one. Second law, Faraday's second law. The magnitude of induced EMF. See, we are not telling direction, we are telling magnitude of induced EMF is directly proportional to the rate of change of magnetic flux, the magnitude of induced EMF is directly proportional to the rate of change of magnetic flux associated with that circuit. Therefore, E is proportional to d phi by dt. E is proportional to EMF induced in that circuit is also called average EMF is equals to change in flux upon time dt. This is generally called average induced EMF. Copy?
Done, sir.
If I is current induced and R is resistance, then we can say I is by Ohm's law E average upon resistance, that is nothing but d phi by dt ka magnitude into 1 by R. So sometimes they can ask you current induced, which is nothing but E by R by Ohm's law. Copy this also. Done. I can clear now. Now based on this
Yes, sir.
laws, we'll see few numericals and then we'll start with MCQ after completing the theory. If the magnetic flux is given as phi equals to 5t square plus 4t plus 1, find induced EMF through the coil, at time t equals to 1 second. So we want induced EMF at 1 second, also called as instantaneous EMF. So 5 is pi t square plus 4t plus 1. How to get induced EMF? By having derivative.
Yes.
What is derivative of pi t square?
10t
10T.
And 4t
plus 4,
plus 4. Now when t is 1, what will be E? 10
14.
into 1 plus 4 equals to 14 volts. Solve.
Done, sir.
Second question. A coil is placed with its plane. Coil is placed with its plane perpendicular to uniform magnetic field. Plane perpendicular to uniform magnetic field of strength 0.5 Tesla if suddenly the coil starts shrinking. Suddenly coil starts shrinking at the rate of 0.1 millimeter per second. Find the EMF induced in conducting circular coil when radius of coil is 5 centimeters. This is the question. A coil is placed with its plane perpendicular to uniform field of 0.5 Tesla. Coil starts shrinking at the rate of 0.1 millimeter per second. Find the EMF induced in conducting coil when radius of coil is 5 centimeter. Question completed. Then I am explaining. Write the question. Similar type has been already asked in JEE main exam. Shall I clear the question?
Yes, sir.
Okay. Aryan, can you tell what is constant in the numerical?
Sir, B,
Yes, B is constant. Who is changing?
area.
Area. So initially, if this is the field with normal area, which is field is 0.5 Tesla, then this coil is shrinking, they are telling. No? Shrinking means it is decreasing.
Yes, sir.
At what rate? dr by dt equals to कितना दिया है? dr by dt
0.1
0.1
mm.
millimeter per
0.1 millimeter. Okay, that means it is 10 raised to minus 4 meter per second. Correct?
Yes.
So we want what is EMF induced when radius is how many centimeter?
5.
5 centimeter. That means 5 into 10 raised to minus 2 meter. So E is rate of change of flux. Now flux change means here turn is not changing, B is not changing. Who is changing? Area. Correct now? What is area of a circle? Is it pi r square?
Yes.
So n is 1, which is constant, B is constant, pi r square ka derivative will be pi 2r dr upon dt. I hope you all followed this much.
Yes.
Yes.
Now n is 1, B is 0.5, pi 3.14 into 2, r is 5 into 10 raised to minus 2 into 10 raised to minus 4. Multiplying these. 0.5 into 3.14 will be 1.57 into 5 into 2 is 10, 10 into 10 raised to minus 2 is 10 raised to minus 1 into 10 raised to minus 4, 10 raised to minus 5 volt. Everybody has understood this sum? Yes,
Yes, sir.
Ananya followed?
Yes, sir.
Please solve. Write the solution. Ananya, last test, what was your total marks?
So I got 136.
You were told, I think, 136.
No, this is a Sunday paper.
अच्छा 136. 10 मार्क थोड़ा कम है. Not bad, but दिल मांगे more, no?
Yes, sir.
This Sunday again test is there?
Today there is actually on electrostatics and capacitors.
So those part तो you are more comfortable, I think.
Yes, sir. Yes, sir.
चलो देखते हैं आज कितना आता है.
Yes, sir.
Done, sir.
Chalo, can I clear this now?
Yes.
So you got idea now how to use Faraday's law of electromagnetic induction. By Faraday's law, we get what? Magnitude, no? So remember, whenever they say direction, then direction of induced EMF or induced current, direction of induced EMF or induced current is found by Lenz's law. So what is Lenz's law? It states that the direction of induced EMF or induced current is such that it always opposes the cause producing it. It always opposes the cause producing it. Let us see first one example, then many more I am giving. Suppose this is current carrying conductor. Current is increasing in nature. I want what is current direction induced in first coil and in the lower second coil. In CBSE, this has been asked in many times in board exam. Now, I want to find what is current induced. So first, it should be having change in flux associated. To have change in flux, there should be magnetic field. What will be direction of field if current is moving in a conductor AB in right direction? Can you tell? What will be direction of field in first coil? What will be direction of field by right hand thumb rule?
Inward.
इनवर्ड नहीं, लोअर वाले कॉइल को इनवर्ड जा रहा है ना, अपर वाले को तो आउटवर्ड आएगा. देखो
Yes,
पेन
sir.
हाथ,
Lower.
लोअर वाले को इनवर्ड आएगा ना, क्योंकि
Yes,
आपका पाम इनवर्ड जाएगा इधर, और अपर वाले को कैसे आएगा?
outward.
आउटवर्ड. सो कैन आई से इन फर्स्ट कॉइल field is outward and increasing, na, because current is increasing. Not followed?
Yes.
Field is outward by right hand thumb rule. Current is increasing, matlab B will be increasing. By Lenz's law, it should be opposed. Oppose matlab decrease करूँ ना उसको.
Yes.
दो वेक्टर सेम डायरेक्शन में डिक्रीज होता है क्या इंक्रीज होता है?
Increase.
Increase.
Increase होएगा. So if they are in opposite direction, then only difference and answer will be decreasing. So outward must be decreased. That is possible if I have inward field. You got it now? Hello?
Yes, sir.
So if we want inward direction of field, current should be in clockwise direction. So in upper one, current is in clockwise direction. Any doubt in understanding direction of current by Lenz's law in the coil number 1? Hello?
No, sir.
Now tell me for second coil. In second coil, field is inward, again increasing. By Lenz's law, it should be decreased. Inward will be decreased by outward field. Outward means current should be in anti-clockwise. So here it is clockwise current, and in this case it is anti-clockwise. Please write properly everything. Many more I'm doing the examples, so you'll get idea of the direction of current and induced EMF. This is the only difficult part because direction we have to predict by understanding. Rest all are theoretical, so if you know theory, you'll be able to by heart it.
Done, sir.
Okay. See the next example. This is inward field. Cross means inward field. Increasing. Here is a coil. You all tell me what will be direction of current by your common sense. Field is inward and increasing. You have to tell me what will be direction of current.
Anti-clockwise.
Anti-clockwise.
Correct. Because inward, this is increasing, so we have to decrease. Inward will be decreased by outward. Anti-clockwise is direction of current. Perfectly right. This is current carrying conductor. Here we have coil. This current is increasing. Now tell me direction of current in this coil.
Clockwise.
Okay. इसका फील्ड कौन सा डायरेक्शन में आएगा?
Outward.
Outward.
Very good. Right hand thumb rule. Thumb upward. If it is on right side, my palm is going inside. Left के लिए वो बाहर आ जाएगा. बाहर आया मतलब outward. So here the field is outward. You are extremely right. Outward but increasing or decreasing? Increasing because current and field are directly proportional. So increasing should be decreased. Outward will be decreased by inward. Inward means clockwise, rightly said. So everybody has understood? Tasmay? Tasmay,
Yes, sir.
yeah, please copy.
Done, sir.
Next one. This is coil. This is current I decreasing. This also I am not doing. You have to explain me. Aniket, explain how to get direction of current.
The direction of magnetic field is inward.
Very good. Field is inward. Okay. इनवर्ड तो रहता है ना, इंक्रीजिंग है क्या डिक्रीजिंग है?
Decreasing.
तो क्या करना चाहिए लेंजेस लॉ के हिसाब से? इंक्रीज.
Increase.
इनवर्ड को कौन इंक्रीज करेगा? इनवर्ड इनवर्ड मिलके ऐड हो जाएगा ना, तो इनवर्ड विल बी इंक्रीज बाय इनवर्ड वेक्टर. इनवर्ड मींस क्लॉकवाइज. आई होप
Clockwise.
अभी समझ रहे हैं 90% बराबर.
Yes, sir.
ओके, कॉपी सेव. Fourth one done.
Yes, sir.
Yes.
This is one straight conductor carrying constant current. Here there is a coil which is moved with velocity v. You have to tell me what will be the direction of current if there is any. Current is constant in the conductor placed in the neighboring to the coil. What will be the nature of field associated? Inward?
Inward.
Inward. Is this field constant or it is changing with the coil?
Constant.
No.
Change.
See, field is inward. Field is constant, that is true, but with the coil I said. So field is inward by our right hand thumb rule, but constant. This also you are correct because current is constant. Here coil is pulled out, na?
Yes.
Coil is pulled out from the field. Now what you can say?
It's decreasing.
That means field associated with the coil is decreasing. So field is inward, decreasing. By Lenz's law, it should be increased.
Yes, sir.
Yes, sir.
Inward will be increased by whom? Inward only.
Inward.
Current will be in clockwise. Okay. Any doubt? Tasmay? Aniket?
No, sir.
No? Aryan?
No, sir. Got it.
ठीक है. Rahul Ankita followed?
Yes, sir.
Sir.
मतलब देखो जितना लगता है उतना डिफिकल्ट है नहीं, बट रेगुलरिटी इज रिक्वायर्ड.
Done, sir.
Okay. This is current carrying conductor and this is coil moved parallel to this. Current is constant. Now just tell me what will be the current induced if any?
So no current induced.
No EMF, no current. No current or EMF induced. Why, Slesha? No current, no EMF?
So because field is uniform.
Field is uniform and it is moved parallel to the field. Na? So it is coming along with the field. So area associated with the field will always remain constant. Therefore, no current or EMF is induced. Okay. Everybody followed?
Yes.
This one, tell me. This is the field, region of field. At one place, coil is entering, then it moves inside this. Now tell me, will there be EMF induced in the coil when it enters?
Yes, sir.
Yes, sir.
In first case, there will be. Second case, no, na? Because field zero, area constant हो जाएगा ना इधर अंदर.
Yes, sir.
So in first case, field is inward but increasing. So we have to decrease it. Decrease means outward. So anti-clockwise. But at position 2, field is constant. So here anti-clockwise current, at 2, no EMF. Okay. Draw the diagram and write the analysis. एक और लास्ट आपसे पूछता हूं मैं.
Done, sir.
One question I'm giving for everybody. I will not solve that. You have to answer me. This is circular region. Half part has decreasing field and half part has outward field. Here inward is increasing and outward is decreasing. I want what is current in the two part of the coil. Take 2 minutes, predict your answer and then explain. Inward field is increasing, outward field is decreasing in upper and lower half of a coil respectively. So we are interested in what will be the direction of current in the two.
Anti-clockwise in both.
Correct. Correct. Now in first part of coil, field is inward, increasing. So we have to decrease outward entry. First part over. Second part, field is outward, decreasing. So you have to increase it. Outward will be increased with outward only. Entry. So दोनों में same direction. All of you got same answer?
Yes, sir.
Yes.
ठीक है देखो. Completed?
Yes, sir.
Okay. One magnet has how many poles? Magnet has how many poles?
2 4.
2 poles. So when north pole of magnet facing the coil is brought towards the coil. So this face of coil facing the magnet will behave as which pole? By Lenz's law. North is coming closer, we have to oppose. So this must behave like north.
Yes.
Then only it will repel. Hai na? So what will be the direction of current? Anti-clockwise. Okay? Hello?
Yes, sir.
So face of coil facing magnet behaves as north pole. See, I wrote the word face of coil facing the magnet behaves as north pole. So this I, if it is on the right hand side, so for observer on right hand side, can you tell what will be the direction of current?
Clockwise.
Yes, because for that he will, for him it will appear like south pole. So for observer on right hand side, direction of current will be clockwise, because for this front face it is north, but this side is south na? As face towards observer will, observer will behave like south pole. Very important part, from where you are looking. Anybody who has not followed this? Hello? Aryan, you followed?
Yes, sir.
Everybody has followed? Meaning,
Yes, sir.
yeah, write everything properly. This is the only where we will make mistake. Because किधर से देखा वो समझा नहीं है तो wrong हो जाए.
Done, sir.
Okay. If this is solenoid carrying current like this, and moving closer to the coil, we want what is direction of current from left hand side. ये करंट क्लॉक है क्या एंटी क्लॉकवाइज है ये एंड पे एट दिस एंड?
Anti-clockwise.
Anti-clock.
Very good, very good, very good. क्योंकि it is going from inside and coming out. So when you hold the pencil inside out, see it will become anti-clockwise. So here current is anti-clockwise. So ये face north pole हो गया ना?
Yes.
ये south हो जाएगा ना फिर?
Yes.
So north is coming closer. ये क्या बनेगा? North pole?
Yes, sir.
So from end one, north pole, that is current anti. Correct na?
Yes, sir.
But from observer, south pole, I am correct or not? ये
Yes,
ऑब्जर्वर इधर है ना पीछे साइड में, दैट इज करंट क्लॉक. नाउ एवरीबडी हैज फॉलोड दिस क्लॉक एंटी कैसा होता है इन केस ऑफ मैग्नेट? यस अनन्या, एनी डाउट?
Yes, sir, no doubt.
प्लीज कॉपी. If this you have understood, then entire chapter is easy for you because there is no imagination in further part. Only I have to retain the formula in my brain. This Sunday will be January 10th, I think, where you have got test on magnetic field and magnetism. 17, 24, 31. This 3 Sunday, electromagnetism combined for you all. This 3 test. 1, 2, 3. Full electromagnetism combined. 3 test. ये perfect हो गया ना तो आपका एटलीस्ट कितना एमसीक्यू मिनिमम 12 तो आई कैन प्रेडिक्ट 12 to 15. सो 50 मार्क आपके पॉकेट में आ गया. अभी और स्कोर करने हैं अपने को 90 मिनिमम. So the total becomes 140. Yes, done this one.
Yes, sir.
चलो एक ये बताना. This is North Pole, South Pole, coming down. This is the coil. Question is A equal to G. इसका acceleration is A coming downward. Second, A is greater than G. Third, A is less than G. Fourth, can't be predicted. Can't be determined. A magnet is falling freely. Then what will happen if there is coil below this? A is G or greater than G, less than G. Earlier it was falling freely. We want acceleration. What is acceleration of magnet?
Sir, less than G.
Less than.
Less than G? Yes, because this will oppose, na? This will oppose by force. So acceleration will be less than G, perfectly right. In this case, what will happen? See, this is the magnet. It passes away downward. Now what will happen?
So still less than G.
Still less than G. Because there is change, whether it comes from up to down or goes from coil to the downward direction. Both cases less than G. हो गया, रब करो. एक थोड़ा सा डिफिकल्ट न्यूमेरिकल टाइप क्वेश्चन है.
Done, sir.
थोड़ा सा डिफिकल्ट है, नॉट वेरी डिफिकल्ट. फाइंड induced EMF, comma induced current and total charge that flows from t equal to 0 to t equals to t naught. t equals to 0 to t equals to t. चलो इधर का स्टार्ट से 0 से t तक इंड्यूस्ड ईएमएफ, इंड्यूस्ड करंट एंड चार्ज चाहिए. If this is coil of radius r placed in magnetic field where B equals to B naught T square, ये क्वेश्चन है अपना. Resistance is equal to R ohms. So if field is also varying in nature, definitely induced EMF will come, because when time changes, field is changing. So we want induced EMF, induced current, total charge. Question written, then first I will find flux, then change in flux, that will give EMF, then current by dividing, then charge के लिए rate of flow of charge is called current का concept. Written question written na?
Yes.
The flux is B bar dot A bar. Now B is perpendicular inward, area vector is also perpendicular, so both are in same direction. BA cos 0, that is nothing but B into area A. B is B naught into T square and area is pi into radius R square, so we got flux. Now we are interested in induced EMF, which is rate of change of flux. So E is rate of change of flux in magnitude. Pi R square is constant, P naught constant, T square का 2T. Okay? Hello?
Yes, sir.
Copy this much.
Done, sir.
Okay. So we got induced EMF, now we'll get current. To get current, we require E by R formula. So I is E upon R. E is nothing but B naught into 2T pi capital R square upon resistance small r. This is also over. Now since I is rate of flow of charge, so dq is I dt. Therefore dq will be I B naught 2T pi R square upon R dt, integrating B naught constant pi R square constant, small r constant, 2 constant, integral of t dt from 0 to t. That will be, therefore total charge q is equals to B naught pi R square upon small r to T square upon 2. This will get cancelled. So q equals to B naught pi R square T square upon R. Clear? Hello?
Yes, sir.
Can you tell direction of the field? Direction of that EMF or current? See, field is inward, correct na?
Yes, sir.
And increasing, because time increases, it is directly proportional to,
Anti-clockwise.
and it is increasing. So we have to decrease it. Decrease के लिए outward. Yes, anti-clockwise. Correct. Anti-clockwise. Copy this much. So if they ask direction, direction of the current is anti-clockwise.
Done, sir.
Okay. Note right down. Since E equals to d phi by dt, so I into R d phi by dt. This means I dt equals to d phi by R. Therefore, dq is d phi by R. So total charge Q will be phi 2 minus phi 1 upon R. This is also one formula. So whenever they give flux and they ask what will be the total charge induced in during that time, it will be phi 2 minus phi 1 upon R. Practice this properly. Next class we'll see what is motional EMF. Motional EMF means due to moving the conductor, there will be two EMF obtained. I don't know whether you are knowing BLV and half BL square omega.
Done, sir.
So that's all for today. Tomorrow again we'll continue with this chapter. 2 lectures it will be required to complete the theory of